Hi, good morning. I'm Manuel Alejandro Chavez Ortega, and I will present the application of electrical impedance spectroscopy as a surface characterization technique for copper sulfide thin films obtained by chemical bath deposition. This is the abstract of my work, and I will begin with the experimental part, the methodology. We first clean the substrates where we're gonna deposit the thin films. They were from indium tin oxide with polyethylene terephthalate to grow the copper sulfide by chemical bath deposition. The substrates were cleaned with isopropanol and deionized water. In the case of the glass substrates, were cleaned also with acetone. Then the clean substrates were submerged in the chemical bath deposition solution with the different precursors of the copper sulfide like copper chloride, urea, triethanolamine, and ammonium uh, hydroxide. We studied 3 times, 10 minutes, 20 minutes, and 30 minutes to see how the thin film was growing in homogeneity, and the temperature was of 37 degrees. Then the thin films were characterized with scanning electron microscopy, profilometry, and electrical impedance spectroscopy. The results showed for SEM images that we obtained a non-homogeneous deposition after 10 minutes. Then a more homogeneous deposition was obtained after 20 minutes. And in the last time, 30 minutes, which is the used for this normal chemical bath deposition method, we obtain a completely homogeneous deposition. To have quantitative result that supports these results, first we carried out profilometry, where we have a increase on the thickness of the thin film. First, around 2050, 250 nanometers, sorry, then 400 nanometers and 500 nanometers after the complete deposition with 10, 20, and 30 minutes. And by list, we obtain the electrical impedance spectroscopy for every thin film. We have a 440 ohms measurement after 10 minutes of deposition. Then we have 340 ohms after the 20 minutes deposition, and the last result was 300 ohms for 30 minutes, which it's consistent with the literature, because when we have a better deposition with more homogeneous thin films, the electrons could hop from pair and electron pair in a better way. So the current increases and the resistance tends to decrease. So observing an impedance decreasing in these Nyquist plots as the chemical bath deposition was carried on with an increase on the homogeneous deposition of the thin films, leads us to support our morphology results or micrographies with the electrical impedance spectroscopy measurements obtained with this method. So as a conclusion of this work, we could tell that the deposition homogeneity of copper sulfide increases proportionally to deposition time as observed in the scanning electron microscopy, with less homogeneous deposition at 10 minutes and the most homogeneous thin film deposited after 30 minutes. The thickness of the copper sulfide thin films increased with deposition time as measured by profilometry, reaching about 250 nanometers at 10 minutes and 500 nanometers at 30 minutes. The profilometry measurements depends on the measurement location for each thin film, and the electrical impedance of copper sulfide thin films decreased as sample homogeneity increased, reaching 414 ohms after 10 minutes of deposition and 300 ohms after 30 minutes of deposition. This is due to enhanced electron hole recombination as grains come closer together and the number of boundaries decreases. So we conclude also that this impedance measurement can lead us to have quantitative results that support our morphological results and make another way to ensure the homogeneous deposition of thin films with electrical impedance results. Thank you for your attention, and I hope to see you next week on the International Material Research Congress for any question, any doubt of my project, or also you can leave any question here in the Woven app. Thank you.